The purpose of this video is to examine the relationship between pressure and fluids water and analyze how the water pressure changes with different heights, namely a height near the surface compared to its deep bottom. This also will allow us to understand where we feel pain or pressure on our ears when we are trying to dive down the water. Thus, this aim would be achieved by constructing an apparatus that would be used for performing this experiment.
Firstly, we assemble the connectors and attach plumbing tape to them to prevent any leakage. However, in the end, these long grey pipes were detached from the apparatus due to their long length.
We pinpointed the desired locations of the holes and measured the distance between them.
Using the appropriate size hole cutter, which is 22 millimeters, we drilled 3 holes at the marked locations.
Using a file, we smoothened the holes to prevent leakage.
First, we drilled multiple small holes surrounding the opening, so then we can use a larger hole cutter to drill through it so our hands can fit in.
Thanks to the large hole, our hands went through the tank so that we can tighten the connections. Additionally, we have used a generous amount of plumbing tape on the connections to reduce the leakage.
Plumbing tape was used in all the connections, especially in ones where there are threads present.
We attached the pipes and valves together using a glue to prevent the leakage.
As a precaution, electrical tape was placed on all of the joints.
Due to it being a vulnerability, clay was placed around the connection of the tank.
We attached the balloons to the connections end and applied electrical tape on them.
To make the water more vivid, we've added blue water dye so that our vision of the phenomena can be clear.
After opening the first valve, we noticed that the air pressure overcame the water pressure and bubbles were formed at the top. The same happened after opening the second valve. Unfortunately, at this point, some leakage had occurred. After opening the third valve, at this point, the water pressure overcame the air pressure inside the balloon and the balloon began to fill with water.
As can be seen at this figure, this is a sample of the apparatus that we built. We drilled 3 holes in this water tank, the first one at 5 centimeter depth, the second one at 17 centimeter depth, and the third one at 29.5 centimeter depth. And we attached pipes, valves, and balloon to each of these pipes. To find the formula P equal rho GH, we combined multiple equations together. The first one is pressure is equal force over area. Now we take the equations of the force. force equal mass multiplied by gravity. And we also know that mass equal density multiplied by volume. Now we take the density and the volume and substitute them in place of the mass. We get force equal density multiplied by volume multiplied by gravity. And we also know that the volume equal area multiplied by height. So we take the area and the height and we put them in place of the volume. We get finally force equal density multiplied by area multiplied by height and multiplied by gravity. Now we take this long equations and put it in place of the force in the first equation. So we get this equation and we cancel the areas together. We get the final equation as pressure equal density multiplied by height multiplied by gravity, which is P equal rho GH. As for the molecules, air naturally has distant molecules, so they try to occupy more volume by exerting pressure on the water, and the water tries to push back. And also, as can be seen in this figure, that the deepest hole exerts the highest pressure, and as we go up, the pressure decreases.
As mentioned earlier, P equals rho GH, and because rho, the density of water, is a constant, and G, the acceleration of gravity, is also a constant, it is possible to conclude that P pressure is directly proportionate to height, or rather, the depth from the surface of the water. This formula, P equals rho GH, can be applied to the current case because we have the depth of each hole and the constant density of water. When substituting in the equation, we get that the gauge pressure at the first hole of depth 5 centimeters is 0.49 kilopascal. This gauge pressure can be added to the atmospheric pressure, which is assumed to be 101.325 kilopascal, to get an absolute pressure of 101.816 kilopascal. These pressures continue to increase the deeper we go from the surface of the water. For example, at hole 2 of depth 17 centimeters, the gauge pressure is 1.668 kilopascal. And at hole 3, at depth 29.5 centimeters, the gauge pressure is 2.89 kilopascal. This pressure of 2.89 kilopascal is generated from only a depth of 29.5 centimeters from the water surface. Now imagine if you were in a pool that's, let's say, 2 or 3 meters deep, and you continue to dive deeper. The pressure generated by the water would be immense on your eardrums. This is why when you go down in a pool, our ears feel pain and maybe even about to burst.
For the bright side, this phenomenon can be utilized in application. For example, a dam that can hold a river can take advantage of this phenomena, such as the Three Gorges Dam located in China. As previously said, the greater the column of depth is, there will be more water weight acting downwards, which causes pressure to increase. Therefore, water will flow strongly through the turbines, causing its blades to spin, in which the generator will convert its movement to electricity, creating hydroelectric energy.
While doing the experiment, some difficulty we are faces, which including the limited time to perform our experiment and limited space and leaking from the bed even after we put in the clay. And the last one is the limited equipment to work with. To avoid this issue, we come up with some recommendation for our experiment to accuracy the result. Firstly, the time should be managed while the blade should be on full to work it. And secondly, we have to allowing the clay to get it dry. And the third one, we have to be a short connector or a short pipe to avoid the leaking. And the water valve, we should not open at the same time to get a good water flow. And the last one, we have to reduce the water amount to reduce the water pressure on the bottom.
To conclude this video, it's safe to say that the experiment has reached its main goal, which was to find the different pressure levels in a water surface. And some of the things that we have learned while doing the experiment was that at different sea levels, there's different pressures, which means that if the more higher you swim, you will face less pressure on your ears. Whereas the more you dive deep down to the bottom, you will feel your ears hurting from the pressure of the water, which is why it's advised to swim at higher levels when going to any beaches or pools. We have also seen the theoretical calculations behind this phenomena by providing mathematical formulas to assist us with this calculations, and we've also provided experimental recommendations in order to improve the experiment and make it more accurate to obtain a precise value. Moreover, we have seen the engineering applications of this phenomena, where in multiple aspects you can see that the pressures affect different surroundings when it's exposed to different heights.